So it'll turn out, and you don't need to know this right now, that the arguments for our trig functions, the things we're going to be putting in, will be themselves angles. And I know that seems kind of weird, but don't worry about that right now. In this video, I just want to define some vocabulary for angles so that we can use this later on. For a lot of people, a lot of this stuff will be review, which is great. Hopefully that'll make it a little bit easier for you. But there'll probably be a couple new things that you pick up here and there that'll benefit you going forward. So without further ado, angles. When I talk about like a 45-degree angle, you probably already have a pretty good idea of what that means. Degrees are a unit that we can use to measure how big an angle is. And the size of an angle just kind of refers to the way the two line segments that create this angle meet up. A 45-degree angle is one where one of the line segments is kind of diagonal to the other one when they meet at this point called their vertex, which hopefully is all stuff that you are already familiar with. What we're going to do when we talk about angles in this class is we're going to start out measuring them in what's called standard position. So when we talk about standard position, what I mean is the vertex of the angle, we're going to put it right here on the origin. We'll have our x and y axes just to kind of orient everything. And while we start with one of the line segments on the positive side of the x-axis here, and we'll measure our angle counterclockwise, so kind of going up in this direction. And a 45-degree angle would be the angle that if we start down here on the positive x-axis, we kind of get halfway over here to the y-axis. If instead we got all the way to the y-axis and we were again measuring things from in our standard position here, we would have a 90-degree angle. You may have heard of the term right angle for a 90-degree angle. A 90-degree or right angle just happens when the two line segments that create the angle here meet up perpendicularly. And for a lot of purposes, we don't even need to go past 90 degrees. We can just consider the angles in between 0 and 90 degrees. But for our class, we're going to want to continue. And for example, we'll want to be able to talk about the angle that starts out on the positive x-axis and goes all the way over here to the negative x-axis. I don't want my picture to be too hard to read, so maybe I won't actually depict that. But an angle that went from here all the way over to here would be 180 degrees. Why? Well, you can kind of think about it as the sum of two 90-degree angles, right? It's 90 to here, so it'd be another 90 to here. That'd be a 180-degree angle. And there's no reason we can't go all the way down here. That would be a 270-degree angle. And here you might take exception to this angle measured in orange being 270 degrees because it kind of might feel like a right angle and it might feel like it's 90 degrees. But again, since we measure these from our standard position, we start out on the positive x-axis and measure them counterclockwise, not clockwise. This is a 270-degree angle that's pictured. It's not a 90-degree angle. A useful way to think about degrees is it's 360 degrees to go all the way around the circle. So if I'm just going halfway around the circle, well, it'd be half of 360 degrees. That's why this is a 180-degree angle. What if I'm just going a quarter of the way around the circles? Well, a quarter of 360 is this 90-degree. In blue is pictured an eighth of a way around the circle, an eighth of 360 is 45 degrees. For most people, degrees are something that are already familiar when you enter this class, but what you'll see is as we become more and more advanced dealing with angles, we'll use degrees less and less. Instead, we'll use different units that are called radians. And I'll define radians for you. I'll show you where the measure of radians comes from, and it's kind of interesting. But typically, classes start out by showing the definition, and I think that kind of confuses people. So I think what might make it easier is, if we think about degrees as 360 degrees is what takes you all the way around the circle, and then we can come up with any of these other ones, 90 or 45 or 270, by just thinking about what fraction of the distance around the circle we've gone. Something very similar will work for defining radians. Radians are just another unit used to measure angles. Kind of like we can use feet or meters to measure distance, we can use degrees or radians to measure angles. And what I think will make this as easy as possible is, instead of thinking of 360 degrees as one lap around the circle counterclockwise, and then fractions of it tell you how far around the circle you've gone, think about 2 pi is the distance once around the circle. And then if we're not going all the way around the circle, we just figure out, okay, what fraction of 2 pi have we traveled around the circle? You might be wondering why 2 pi is all the way around the circle, and I'll get to that, I promise. But for now, just trust me that 2 pi is all the way around the circle. So if I wanted to measure this angle, which we already said was 45 degrees here in blue, except I didn't want to use degrees, I instead wanted to use radians, all I'd have to do is figure out what fraction of 2 pi I have to travel to get this far. Well, this 45 degrees is halfway in between my x-axis and my y-axis, and traveling to my y-axis is a quarter of the way all the way around the circle. So I've gone half of a quarter of the way around the circle. This is an eighth of the way around the circle. This is 1/8 of 2 pi, but 1/8 of 2 pi is the same as 1/4 of 1 pi, which is typically written as pi divided by 4. What I'm saying is this angle here, you could write it as 45 degrees, or you could write it as pi over 4 radians. This little circle up in the superscript is the symbol that we use for degrees. There isn't something analogous for radians, so often people just write RAD as an abbreviation for radians, or if it doesn't explicitly say degrees, I can just assume it's radians. So when I see pi over 4, I'm not thinking, okay, pi is like 3.14 or so, and 3.14 divided by 4, that's like 0.7 or 0.8. I'm not thinking 0.7 or 0.8 degrees, I'm thinking pi over 4 radians. In case that didn't make sense, let me talk about these other angles. We said a 90-degree angle, aka a right angle, is the one pictured here. What if we wanted to express that same angle, except instead of using degrees, we wanted to use radians? Well, there's several options, but maybe the most straightforward would be it's 2 pi to go all the way around the circle, and this is going a quarter of the way around the circle, so it's a quarter of 2 pi. A quarter of 2 pi is the same as a half of pi, which is typically written as pi over 2. For this video, I'll include RAD in all of these, but what you'll see is quickly I'll drop that off, and you'll be able to tell just from the context. Pi over 2, oh, I bet he's talking about radians. One more, this 270-degree angle. Well, let's see, that's 3/4 of the way around the circle, and all the way around the circle is 2 pi, so I want 3/4 of 2 pi. 3/4 of 2 pi is the same as 3/2 of pi, which is typically written as 3 pi over 2. This angle here is 3 pi over 2 radians. Just like we could think about degrees as just some fraction, how far around the circle we're going, of 360 degrees, we can think about radians as some fraction, how far around the circle we're going, of 2 pi. It's worth pointing out that it works out a little bit easier numerically to, instead of thinking about 360 degrees as all the way around the circle, think about 180 degrees as halfway around the circle. So if we had to figure out how many degrees this was measured in green, which I know you're probably already familiar with, we could think about this green here is halfway to get to here. It's halfway to get to halfway around the circle. So it's half of 180 degrees. Half of 180 is this 90. This 45 degrees is a quarter of the way to get halfway around the circle. A quarter of 180 degrees is 45 degrees. Similarly over here, instead of thinking about 2 pi as all the way around the circle, you could think about pi as halfway around the circle. And that makes the fractions work out a little bit nicer. If pi is the distance halfway around the circle and green is halfway to halfway around the circle, then green is just half of pi, in other words, pi over 2. Blue is just a quarter of halfway around the circle, so it's pi over 4. For orange, we get halfway around the circle, and then we get another half of the halfway around the circle. So I get 1 1/2 halves, and since halfway around the circle is pi, 1 1/2 pi I can think of as 3 pi over 2. Before ending this video, I want to talk a little bit about why 2 pi is once around the circle. You're like, yeah, 360 degrees, that makes sense. And I'd argue, does it really? Or is it just you're more familiar with this? What does 360 degrees have to do with this circle? Why is 360 degrees once around the circle to begin with? I think originally it comes from astronomy and people thinking there's about 360 days in a year, and so it takes that long for the Earth to make a lap around the sun, give or take. But the derivation really isn't all that important. You understand that 360 degrees is defined to be once around the circle, and then we can measure any other angle just based on that assumption. It's kind of the same logic here. Why is 2 pi all the way around the circle? Well, don't worry about it. It is all the way around the circle. And once you accept that 2 pi is all the way around the circle, just like you accept that 360 degrees is all the way around the circle, we can measure any angle as what fraction of 2 pi is it equal to. And you're like, so you're really not going to tell me why 2 pi is all the way around the circle? No, I'll tell you. I'm just trying to make the argument that you don't really need to know where it comes from. You should just accept that 2 pi is once around the circle. But where this comes from is if you have a circle whose radius is 1. So if I draw that circle centered at the origin, then one point on the circle would be 1, 0 here. The radius, the distance from the center to any point on the outside of the circle, is 1. At some point in your geometry background, you might have memorized these two formulas. All right, the area is pi r squared and the circumference is 2 times pi times r. This circumference equals 2 times pi times r is where the radian formula comes from. If we have a circle whose radius is exactly 1, then the circumference, the distance around the outside of this circle, would be 2 times pi times 1 if the radius were 1. So the circumference, the distance around the outside of this circle, is just 2 pi. Pi over 4, for example, is the distance that, I don't know, like a little ant or something would have to walk if that ant were walking around the outside of the circle to get between the 2 points that define this angle. The reason this angle is pi over 4 is because if we had a circle with radius 1, which is called a unit circle, and I were walking around the outside of that circle, I'm a tiny little ant, the distance that I would have to walk would be pi over 4 units. If I walked all the way around this circle, I would walk 2 pi units. So really, you could think about radians as just the distance around the outside of a unit circle. And while that's 100% true, I don't usually add that until the end of this video because I think it just confuses things. Even though that's where these came from, don't think about radians as the distance around the outside. Think about radians as a unit that you can use to measure angles. And yeah, it comes from the distance around the outside of a unit circle, just like degrees comes from, I think, the Earth traveling around the sun in 360 give or take days. But none of that is at all relevant. All they will be in our class is units that we can use to measure different angles. And if you can follow that this angle right here is pi over 4 radians and can also be measured as 45 degrees, that's great. That's all I was trying to get out of this video.